Hello guys, my name is Yusuf Saiwa Matilda and today I'm going to be teaching you Hooke's law under physics. Firstly, Hooke's law is a law that is applied when a given force is exerted on an elastic material such as a spring. This law was originated way back in the 17th century by a British physicist called Robert Hooke. And it states that the force applied on an elastic material is directly proportional to the extension produced by that material. So we're going to bring that out on the board. The force applied on the material, take it as F, is directly proportional, that's proportionality sign, to the extension of produced by the material. Therefore, F is directly proportional to E. So to remove this proportionality sign, we are going to introduce a constant. F is equal to Ke, where K is the constant called stiffness or spring constant. Thank you. Hello guys, I'm back and this is question 1 under Hooke's law. It says when a force of 100 Newton is attached to an elastic material, its length changed from 100 centimeters to 101 centimeters. Calculate the Young's modulus if the cross-sectional area is 2 centimeters squared. It's very important to bring things out so that we can be able to know the formula to use. So I'm going to be bringing out all the quantities here. So they said when a force of 100 Newton, we'll bring it out. F is equal to 100 Newton. Is attached to an elastic material. Its length changed from 100 centimeter to 101 centimeter. You have to note that before there was any extension, that's from 100 to 101, this was the length. So we'll say, since there are two lengths, we'll take L1 to be 100, where L1 is the initial length, which is the first length, 100 centimeters, and L2 is equal to 101 centimeters. So we are going to get the extension with this L1 and L2. Therefore, extension is equal to L2 minus L1. That will be the final length minus the initial length. So extension will be equal to 101 minus 100, which is 1 centimeters. So we have gotten the extension now. Let's read further. Calculate the Young's modulus. So this is the symbol for Young's modulus. Note that if the cross-sectional area is 2 centimeters squared, we already know that area is denoted with capital letter A, so put it equal to 2 centimeters squared. So I'm going to be forging the formula that we are going to be using right now. So that's going to be Young's modulus, let me write the Young's modulus here, is equal to stress all over strain. So that's Young's modulus is equal to stress over strain. And stress is force per unit area, which is force over area, and strain is extension per unit length. Therefore, Young's modulus is equal to force over area all over strain is extension over length. So you can see we have like a fraction here all over another fraction. So we'll bring it out as force over area divided by extension all over length. So you know we can't take divides to just be times and go say force over area times extension over length. No. So to change divide to times, we are going to have to invert. Therefore, Young's modulus is equal to force over area. You drop down. And stress is force per unit area, which is force over area, and strain is extension per unit length. Therefore, Young's modulus is equal to force over area all over strain is extension over length. So you can see we have like a fraction here all over another fraction. So we'll bring it out as force over area divided by extension all over length. So we can't take divides to just be times and go say force over area times extension over length. No. So to change divide to times, we are going to have to invert. Therefore, Young's modulus is equal to force over area. You drop down force over area, then we invert force after the division sign to make it multiplication sign. That will be times this length to come to the top, extension will go to the bottom, length all over extension. Therefore, that's going to be equal to force times length is F L all over A E. So to get Young's modulus, you can already see it. Look at, so this L here is L1, which is the initial length, of course. So we'll bring it out. Young's modulus is equal to F is what? 100 Newton. 100 times L is what? L is L1, which is 100 to 100 all over AE. That will be 2 times extension, which is 1. 2 times 1. So I hope you know that numerator can cancel denominator. So we'll say 2 into 2, 1, and 2 into 100 is 50. So we have Young's modulus to be equal to, since this one is already over 1, we don't need this denominator. So that will be 50 times 100, which is 5,000 Newton per centimeters square. So I'm going to have to convert this to standard form. That will be 5 times 10 raised to the power of 3 Newton per centimeters square. Thank you. Hey guys, and I'm back with question 2, which says if a mass of 20 kg is suspended at the end of a rubber cord of diameter 2 mm and the length of 100 centimeters, calculate the period of the vertical oscillation of the mass if the Young's modulus is 2 times 10 to the power of 8 Newton per meter square. So we're going to be bringing out the quantities in this question. So they say if a mass of 20 kg, you bring it out. M, which is mass, equal to 20 kilograms, comma, they said is suspended at the end of a rubber cord of diameter 2 millimeters. So you bring it out. Diameter, which is D, equal to 2 millimeters, and the length of 100 centimeters. L is equal to 100 centimeters. Calculate the period of the vertical oscillation of the mass. Period is capital letter T, question mark, if the Young's modulus is 2 times 10 to the power of 8 Newton per meter square. This is Young's modulus, 2 times 10 raised to the power of 8 Newton per meter square, sorry. So we are going to have to derive the formula. So what we are going to do now is Young's modulus is equal to stress over strain. I know stress is force over area, then all over strain is extension over length. Therefore, Young's modulus is equal to force over area divided by extension over length. To change divide to times, we are going to have to invert. That means the numerator will come to the denominator and the denominator will come to the numerator. That's going to be force all over area. Then after the divide sign changes to times, this length comes to the top all over extension. That's going to be F L all over A E. So we know that Young's modulus is equal to F L all over A E. So balance and cross multiply. So this is 1 all over 1. Therefore, F L is equal to Young's modulus times as area times extension. So divide by L. Therefore, F is equal to Young's modulus times area times extension all over L. Since F is equal to KE, that's from Hooke's law, the beginning. So we replace it here, we substitute KE into F. Therefore, KE is equal to Young's modulus times area times extension all over L. So if we are going to divide both sides by extension, the extension goes to extension here. Therefore, K is equal to Young modulus, so write Young modulus times area all over L. So that's K. So we are looking for period, which is T, and the ones that all over L. So that's K. So we are looking for period, which is T, and the ones that are connecting all these quantities with period is T is equal to 2 pi root m over K. As you can see, we know that K is Young modulus times area all over the length. So we substitute K as since K is Young modulus times area all over length, so substitute it into this formula. Therefore, the period will be 2 pi root m all over Young modulus times area all over length. That will be 2 pi root Young's root m divided by that Young modulus times area all over length. Therefore, T is going to be equal to 2 pi root. To change divide to times, we invert as usual. That will be m times L all over Young modulus times A. That will be 2 pi root ml all over Young's modulus times A. So we are going to be using this to solve. Let me bring it out here. T is equal to 2 pi root ml, that's mass times length, all over Young's modulus times area. So actually we are going to be solving this question too now. This question is involving a rubber cord of diameter 2 millimeters, and we also know that a cord has circular section area. So we're going to substitute into this formula. I hope you know that pi is equal to 3.142. So we're going to substitute. Therefore, period is 2 times 3.142 root, the mass is 20 times the length is 100 all over Young's modulus, which is 2 times 10 raised to the power of 8, and then times, we don't know the area. So since it's a cord, we are going to be using the area of a circle, which says 2 pi r square. Area is pi r square. That will be 3.142 times the radius. We gave us diameter. I hope you know that radius is diameter over 2. That will be diameter over 2, which is 2 all over 2. Remember that this is in millimeters, and this is in centimeters. We are going to be using this formula to solve the question. It says period is equal to 2 pi root mass times length all over Young modulus times area. We have to get the area. Since it's a cord, since it's a cord with circular cross section, we are going to be using the area of a circle, which is pi r square. Therefore, area is equal to pi is 3.142 times r is, hope you know that diameter is radius times 2. Let me bring it up. Diameter is 2r. Therefore, to get radius, we divide both sides by 2. Therefore, radius is diameter over 2. So let's do it in a rough corner here, which is 2 millimeters all over 2. Therefore, radius is 1 millimeter. We are going to be converting everything to meter, that will be 1 times 10 raised to the power minus 3 meters. That will be 3.142 times 1 times 10 raised to the power minus 3. Therefore, all square, of course. Therefore, A, which is area, is equal to 3.142 times 1 square times 10 raised to the power minus 3 square. Therefore, area is equal to 3.142 times 1 square, which is 1, is 3.142 times 10 raised to the power minus 3. Indically, will be these powers will times each other. 2 times minus 3 times power minus 6. That's the area, meters square, because everything was converted to meters. So now we can get solving. Let's get solving. We also have length here, which is centimeters. So to convert centimeters to meters, we divide by 100. Therefore, L is 100 over 100, which is 1 meters. So we are taking this L as 1 meters, because 1 meters is 100 centimeters. Now let's start solving. Period is 2 times 3.142 root mass is 20 kilogram times length, I already told you, is 1 all over, that's the Young modulus, 2 times 10 raised to the power of 8 times the area, which is 3.142 times 10 raised to the power of 6. So we are having here 2 times 3.142, which is 6.284. Let me write it here. Period is 6.284 root mass is 20 kilogram times length, I already told you, is 1 all over, that's the Young modulus, 2 times 10 raised to the power of 8 times the area, which is 3.142 times 10 raised to the power of 6. So we are having here 2 times 3.142, which is 6.284. Let me write it here. Period is 6.284 root 20 times 1, 20 all over. If you multiply all these things, you get 628.4. That will be 6.284 times root 20 all over 628.4 is 0.032. That will be period 6.284 times 6.284 times 0.18, which will give you 1.12 seconds. 1.12 seconds. That's our period. I hope you understood every content of what I just solved on the board. Please like, comment, and share, and also remember to subscribe to our YouTube channels so that I could be the first to be notified when any of these types of videos come out. Thank you.